Hi, Dr. Bryant. Uh, Good news. I'm able to bind both of the modules, and both of these modules are running at one place now. The modules are PyLDAVs and R2 pipe. The problem is I was having many different versions of Python, and when I pip install using one Python, it's getting installed on the other Python version. So uh, I've removed the symbolic link to the Anaconda Python, which is in the Anaconda folder, and I linked it to the other Python which I was having, for which R2 pipe was running fine. So yeah, let me walk you through the code. So here I'm loading all of the modules which I require. So I'm depending on PyLDAVs to generate the visualization, and scikit-learn to generate the LDA models, and latent dirichlet allocation models. There's one to generate the topic topic modeling and all of that. Yeah, so R2 pipe is nothing but a Python binding for R2, and I'm using JSON and URL library because to fetch the corpus from the GitHub, as because like we are fetching the corpus from the GitHub based on the function names we have in the executable. Yeah, so I'm loading the scikit-learn modules, and yeah, that is about the importing the modules. And this section is nothing but getting the function names from the executable and giving it to the GitHub, and then fetching the descriptions from the GitHub response. So let me try. So I'm thinking of trying with all these executables one after another. So let me try with ls first. So this gets the function names, splits on the dot and takes the last word and replaces underscores with plus, so that each word within a function will be given as different names while giving it to the GitHub over URL. And I'm using the access token. Actually, if I don't use my personal access token of GitHub account, the response I'm getting from the GitHub, the text response, is very limited. And yeah, so yeah, the final go is like I'm taking the descriptions and saving it in the list docs raw, which I'm giving it to the TF vectorizer and TF IDF vectorizer to generate the models. So here I'm giving this docs raw to give it to the TF vectorizer such that it generates the clusters based on the similarity based on the TF IDF. So here I have both of them, TF vectorizer and TF IDF. TF is term frequency and TF IDF is term frequency, inverse document frequency. And yeah, here I'm generating the latent dirichlet allocation models, LDA models. Here I have this n topics equal to 5, which means like it creates 5 clusters, each cluster being a group of similar words. So yeah, here I have different graphs, one using TF vectorizer and other using TF IDF, and one using other similarity based measures like MMDS and TNSE, TSNE, etc. So yeah, let me run this for the ls executable, which is at bin.ls, and see how it goes. So I'm using this is based on the IPython's notebook. So let me run run all. So it says busy here, which means like it fetching the function names and getting the corpus from the GitHub and then generating the models. uh, it's it will not take much time, but based on the corpus it gets from the GitHub, it's taking much time, but it'll be generating the visuals. Yeah, I think it's done because we don't see the busy here. Yeah, it's done. So here, as we have given number of topics equal to 5 here, so it has generated 5 clusters. If a circle is having bigger radius, it means like it is more, the terms here are more frequent. So here it says, if I click on this, here it says 28.4% of the tokens are here in this cluster. So from here, the major words present in this cluster are install, echo, tree, service, restart, master, user, and all of these. So if you click on each word, it tells like in which cluster it is contained in. So yeah, we have other ones: read, text domain, project. Yeah, the one which we gave, the executable which we gave is ls. So here ls is the list. So these are different words which we have got from the GitHub, and yeah, I'm seeing like how we could correlate these words with the ls executable. And yeah, these are other different ones based on the different, but we have the same words here, but different different visualizations. So here we have install, echo, and all of this. So let me change the executable. Let me try with strings executable. So run all. Yeah, it has got yeah, it has generated. So the executable which we used is strings. So the top one is player ID. I don't know what player ID is, but it is occupying much of the corpus, but I don't know why this player ID, how this player ID is related to the strings executable. Yeah, I think this is the noise. Yeah, as per your suggestions which you said, like getting the exact corpus based on the hash, function hash, and everything, I think if we try to expand, extend this, like we'll have to try those methods. But here I see we have a lot of noise getting into this. So and int, printf, and all of them. Let me try with the other executable. Sorry. We have nm executable in the line next. Yeah, it is got generated. It is generated. Oh, even with this nm we have player ID standing in the first position, and yeah, the other ones are here we see node, output, socket, route, destination, address, strcpy, get opt. But I really couldn't conclude that based on these words we could tell that it is related to some nm related functionality kind of executable. yeah, I see a lot of noise. Yeah, yeah, play ready, and yeah, let me go to obs dump. So this Python notebook also gives us flexibility to save as HTML, but that HTML is fixed to one executable. I tried giving, there's no flexibility of giving the executable on the fly. I think like we'll have to do it with Django. Yeah, but actually I was struggling to bind both of these modules, and I couldn't spend time for the generating HTML using Django. Yeah, yeah, we're done. Yeah, yeah. Here I see the node as a first node, ODR, index client, rrec, destination, address, nodes, interface. Mm, yeah, almost fopen, fread, socket. Yeah, I think this gives some clues on the executable, but using this, like, we couldn't exactly converge to a particular functionality for the executable. I think, yeah, I don't know, like, I'm seeing much of the noise in this, but yeah, this is one way of getting the uh, interpretations on the executables given here. And yeah, here in this IPython you can download as the HTML, Python, and all of these. Yeah, this is Dr. Bryant. Thank you.